as a new topic. It's called layer 2 port aggregation, or what some people might refer to as etherchannel. Etherchannel, okay? Layer 2 port aggregation. First of all, what is the need for something like this? Well, I might have a need because I want to increase the throughput between two switches. Instead of having one physical line that connects those switches, I want to have multiple lines that connect those switches. But the problem that we run into if we have multiple lines is that spanning tree will actually disable some of those lines unless they're bundled together. To bundle multiple connections together is called etherchannel. We'll see some visual representations of this a little bit later on.
So if you physically connect two switches together, they're not stacked, but you connect them together
With a cable, yeah.
with cables, then you may not actually get what you think you get.
You won't get what you think you're getting unless those cables are bundled together. You absolutely will not. I can guarantee if you just take two switches and run two cables between them, one of those links is going to get disabled by spanning tree. The only way to prevent that from happening is to logically bundle them together and make them look like one interface. And that's what etherchannel is. Etherchannel is the process of taking multiple physical links and bonding them together to make them look like one physical link. Now, you could say, okay, well, if I'm running out of bandwidth between my switches, then convert the link from fast Ethernet to gigabit Ethernet. Yeah, that might work, but it doesn't provide you any redundancy. And there's a limitation to that, right? Because what if you need 5 gigs or 10 gigs to get between the locations? So in order to increase the link speed, we have to add more physical ports. But like I said, unless those ports are bundled together, they're going to look like normal individual ports, and spanning tree can disable those ports. It will, actually. So logical aggregation of similar links provides the solution because we bundle those links together and make them look like one logical link. This provides for two things. It provides for additional speed because now we can load balance across those links. But it also provides for redundancy because if one of those links fails, one of those physical links fails, we still have other links in the bundle that are still functioning. And you can actually create these ether channels at layer 2, or you can create these ether channels at layer 3. They can be routed interfaces, or they can be switched interfaces. Now, there are actually 3 ways to create an ether channel. You can use a protocol called LACP, which is an IEEE standard. You can use a protocol called PAGP, which is a Cisco proprietary standard, or you can use static persistence, meaning that you're not using any kind of protocol. Now take a look at the tables down here. If it's LACP, you can see there are 2 modes of LACP. 2 modes of LACP, passive and active. Notice if it says, if I go active to active, the ether channel will form. If I go passive to active, the ether channel will form. But if I go passive to passive, the ether channel will not form. That is because when you configure an interface as active, it automatically sends out messages saying, I want to be an ether channel. When you configure an interface as passive, it waits to be told to become an ether channel. Does that make sense? So if both sides are passive, nobody's ever going to try to negotiate that ether channel. PAGP is exactly the same way. The only difference is the modes are called desirable and auto. Desirable is an active mode. Auto is a passive mode.
Do switches come with this? Is the protocol already on the switches?
Yes.
You just have to use it?
Mm-hmm. I can't really think of a device, a Cisco switch that doesn't have this functionality built into it.
Has it been that way for a long time?
Yeah.
Okay.
Yeah, we've been using ether channels for a very long time.
Well, I meant built into
Yeah,
the
absolutely.
switches.
Okay? Now, I see very few people actually using PADGP, the Port Aggregation Protocol, because it is Cisco proprietary. If you're doing this link aggregation to a server, you're probably going to use LACP because that's an open standard. All right? But PADGP is the Cisco proprietary version. So let's take a look at a layer 2 ether channel configuration. Look at a couple of examples, and then we'll wrap up this section here. It's a very short chapter. The first thing, of course, you have to identify what ports are participating in the ether channel. All right? You specify a channel group number. By the way, all of this will make more sense when you actually look at the configuration. You specify the channel group mode. By specifying the mode, you're actually specifying the protocol. So to say channel group 1 mode auto or channel group 1 mode desirable, you're using PADGP. If you set the mode to active or passive, you're using LACP. Now, once you create that channel group number on the physical interfaces, then a logical interface gets created as well called the port channel interface. All of your ether channel configurations get applied to that port channel interface. And then the configurations on the port channel interface get carried over to the physical interfaces. But in order to do ether channel, there's a few requirements. Number one, the interfaces all have to be the same type. You can't bundle fast Ethernet and gigabit Ethernet interfaces together. They have to have the same speed, the same duplex. Essentially, every single configuration on the interfaces that are in the ether channel have to be the same. If you make one difference, even a description on the interface, it will not join the ether channel. So it's very important that you make sure that all of your interfaces have the same configuration. So here is that configuration. I want to set up a LACP ether channel between switch 1 and switch 2. I've picked out my interfaces. I'm going to use Ethernet 1.1 and Ethernet 1.2 on the left.